Hey guys, welcome to a new set of notes. Today we're going to talk about the Big Bang Theory. Unfortunately, not the TV show, but definitely how we got here. So, this is section 2 in your notes. So, the Big Bang Theory is basically all of the energy and matter of our universe originally existed in one tiny, incomprehensible, hot and dense state. So, just this tiny little thing. Um, Almost 14 billion years ago, our universe began as a cataclysmic explosion. So that dense, hot, everything, all the forces working together just kind of um, went sideways and exploded. Uh, as it continued to expand, it has cooled and evolved to where it is now. So in the beginning, you had something very tiny and dense. It exploded because it was unstable, and we are where we are right now. Um, Initially, after the bang, only subatomic particles existed. It took almost 400,000 years for the particles to form atoms. And even at that time, the only atoms available were helium and hydrogen. As the universe cooled over time, the primordial gas condensed into the first stars and galaxies that you learned about yesterday. All right, so the first stars, keep in mind when we talk about stars, we're typically talking about sun, um, not just a random shooting star you see in the sky. We're talking about actual suns. They formed roughly about 200 million years ago after the Big Bang. They're primarily hydrogen and helium, generally very monster sized, 30 to 300 times larger than our sun. The bigger stars generally have shorter lives, and we'll get back to the life cycles a little later on. But during the life and death, the stars synthesize the heavier elements and spewed them out into space when they would die. So we got things more than hydrogen and helium. So a couple important notes. 1912, a scientist or astronomer, Besto Slipher from Arizona, was the first to discover that galaxies were actually always moving. Before that, people had thought that the universe was static and nothing moved. That they rotate as well and move in space relative to each other. So there's a rotation and a movement. In 1929, Edwin Hubble, famous for the Hubble telescope, noticed most galaxies were moving away from us, and we'll learn about how he did that. Hubble's law, which you'll look at a little bit more tomorrow, is that galaxies recede at speeds proportional to their distances from the observer. So it's receding, which means it's going away, um, and it's based on the distance from the observer. Like I said, we'll find out more about that later on. This was a huge shift in ideas. Like I said earlier, everyone thought the Earth and the universe, everything was static and unchanging. All right, so some predictions based off the Big Bang Theory. In 1965, scientists found evidence of cosmic microwave background radiation. It comes from the initial hot universe prior to that Big Bang, so that very tiny, dense formation prior to it getting unstable and exploding. As the universe continues to expand, these electromagnetic radiation waves that have a very high energy have now been stretched out to be barely detectable. And this picture right down here is a more recent picture of our universe, not our solar system, not our galaxy, but our universe, of the readings of those microwave background radiation. So radiation is everywhere. So there's a few different possibilities for the fate of the universe. There's really two that are considered the main ideas. One of them is called the Big Chill, and that is where that universe continues to keep expanding, getting bigger from that Big Bang, and it just keeps moving outwards, and everything gets so far away from each other that it cools off and nothing can support life. So over here in the picture, that would be this one right in here. And then the Big Crunch is the opposite of the Big Bang. as the universe expands and will attempt to bounce back and become that initial dense hot spot again. So instead of being an expanding universe, you have one where it's the big crunch and it goes back into that infinitely small point, and would just collapse the entire universe. Think about a rubber band being stretched out and then let go. All right, so it tries to find that initial setting, and that's where that one would come in. There is one that says that we just stay fairly stable and continue, but it's not one of the main ideas. All right, so dark matter. We have 100 billion galaxies in our universe, each of them with billions of stars, clouds, gas, dust, planets, moons, and all sorts of other debris, comets, asteroids, all of that. The closer to the galaxy center, the faster the galaxy should be moving. So like Venus travels around the sun a lot faster than the Earth does because it's closer to our sun. However, this is not true always when it comes to galaxies. So scientists think that there's something called dark matter. It is the cause of everything in the galaxy moving at the same speed instead of that faster speed at the center. No one really knows what it is, but think that it's some sort of invisible force that's tugging on those stars, keeping them at an even pace. If you're a big car fan, it's kind of like almost having a governor. All right, so 25% of the universe is made up of that dark matter. Again, that's an estimate because we really don't know what it is. And it doesn't seem to emit or absorb light, but it still interacts with everything that we can see. And getting into dark energy, in the 1990s, so something relatively recent, scientists thought gravity was going to slow the motion of the universe expanding. So that's kind of that big crunch idea where the universe expands, slows down, and then collapses back into that infinitely small point. The universe is actually speeding up. We're getting further away from each other faster and faster. In order to explain this, scientists came up with the term dark energy. Notice they use the word dark when they don't know what they're talking about. To explain the force that they don't know yet. So are dark matter and dark energy related? Because we've given them both names starting with dark? No idea. Absolutely none. That's still a huge area of research going on. And lastly, there's a video for you guys to watch and a few video questions. It does go into the history of the universe and the different epochs, if you remember your Earth history. And then it also goes into 4 major forces, which you will definitely need to know. So do pay special attention to those. Have a good day.